back, my friends, and we're looking at question 7 now. Let's enjoy it. So, what is the question saying? Show that P satisfies this equation. Show that P satisfies this equation. If I read this statement, I don't recognize the topic. Okay? I need to recognize the topic so I know what to do. I have to. So I'm going to look for something which tells me what to do, because I should know the topic. What am I doing in this one? Is it equation of a circle? What is it? What is going on? So show that P satisfies this equation. What is P? What is P? The diagram shows the curve. Okay, we have a curve, yes. The curve has a maximum point. M, where X is equal to P. This is a joke. Now I know what question it is. This is differentiation. Because I know that the moment they talk about a maximum or a minimum point or a stationary point, it's differentiation. And remember that to get a stationary point, it's not just differentiation, it's an application of differentiation. You differentiate, then you let the derivative equal to 0. Because remember, differentiation, you have the methods, we talked about them, which is one, you have differentiation where you use the power rule, right? Then the differentiation of these functions, Lie8. Power rule is how you differentiate algebraic things. Then you have the differentiation of ln x, the differentiation of tan inverse of x. You need to know it from the table. The differentiation of sine, cos, tan, then sec, then cot, then cosec. These ones you know from the table. Then the differentiation of e to the x. These ones you all know from the table. You need to know how to differentiate this, right? Then you need to know how to use the product rule. Then you need to know how to use the chain rule. Then you need to know how to use the quotient rule. Okay, these are now rules we use when you are combining different functions. For product rule, you'll be combining functions in Lie8 and you'll be making them multiply each other, right? And we'll be knowing how to differentiate them, because we learn in Lie8 in the table how to differentiate ln x, but now we'll be having ln x times sine x, and they want you to differentiate that. Then you use the product rule. For chain rule, okay, let's start with the quotient. For quotient rule, they'll be dividing. Quotient is the division. Then for chain rule, you have one inside another, like ln of sine x, right? You use the chain rule there. It's a composite function. We talked about it. Then you now do differentiation of implicit equations. Then you do differentiation of parametric equations. Implicit equations are equations that you cannot make y the subject. You need to know how to differentiate those. And you got to know also how to differentiate parametric equations, where you have two different equations that are a function of something, and then you want dy dx. Like to say x is a function of t, y is a function of t, so you can get dx dt, you can get dy dt, but you actually want dy dx, so you now need to combine them in a special way to get dy dx. Those are the parametric. You are done. This is differentiation itself. These are the methods you gotta know, and we say you are done with A level. Okay, you gotta know how to differentiate tan inverse. Don't forget that. You're right. Now, when you're done with this, what do you now need to know? You need to know how to now apply to get different things. How to get the gradient, how to get whatever. Here we want to get the maximum point, which is a turning point. This M here, this is a turning point. We need to know how you then get the turning point. What do? You let your derivative equal to 0. So the moment I see the word maximum, I know I have to get the derivative and I have to let it be equal to 0. That's the only way I'm going to get it. And then I'm going to solve, and then I'm going to be able to get what they want. Surely I should get what they want, okay? Because they said at this point, that is the point where you make x equal to p. So when we get to this point, we're going to remove x and we'll put p. But first we need to get to the point. So I'm going to write the equation. Y is... So yes, we rewrite the equation, which would be saying, okay, let me write it nicely to say y is equal to x cubed cos 2x, right? Now, what is the first thing we do? Differentiate it, right? Remember that we said it is an application of differentiation. So you have to differentiate first. So let's differentiate. This is easy. Do you recognize this? What is going on here? The function on the left is an algebraic function. Yes, so x cubed is an algebraic, right? And then cos x is a trig function. You see that? Okay, it's on T for trig functions. Cos is right here, right? And then we know that x cubed is a what? We know that x cubed is a is a polynomial or an algebraic, right? So let's talk about these. These are easy. Right now, let's differentiate these two. We can see that they're multiplying, so the only way to differentiate them is to use the product rule. Product rule says bring the second, multiply by derivative of the first, then plus put the first, then multiply by derivative of the second. I mean, so this is so easy. So if you want to do it in steps, you can still do it. You would say let u be equal to the first thing, x cubed, and then v be equal to the second thing, cos 2x, okay? Because the product rule will be for uv. So you would now say, what is u prime, which is the derivative of u? It is 3x squared. Okay, you drop the power, you reduce it by 1. So the 3 comes down, the power reduces by 1, it becomes x squared. Then v prime is going to be the derivative of cos 2x. Now remember, this is cos 2x, it's not cos x. If it was cos x, we'll just say, okay, you go to MF19, you see these derivatives, right? MF19, let me go to them and show you. Okay, so here's our MF19, and then we go down, we are going to get to the derivatives. Here are the derivatives. Here's our table. Can you see it? Right, you have to know this table off your head. It's good to just know it off your head, but you don't have to know it like that. Anyway, we want to see the derivative of cos. So we come here, we look at the derivative of cos is going to be negative sign. Can you see that? So the derivative of cos is what? Negative sign. But it's the derivative of what? Can you see? It's cos x, not cos 2x. So now let's go and do for cos 2x using this. The derivative of cos would be negative sine x, right? Okay, cool. Let's go and now continue. Now we are doing the derivative for cos 2x, right? So we first do the derivative as if it was for cos x because we differentiate the outside. This is a chain rule question, which I told you that you almost always get composite functions so that you use chain rule. Chain rule will be it's cos of something which is not an x, so it makes it composite. Okay, we have put 2x inside cos. So now to differentiate it, you are going to do what? You differentiate the outside first. The derivative of cos is negative sine, so it's negative sine of 2x. You don't change the inside, right? You just do the cos. Cos was going to be negative sine, but the inside will still be 2x. Then you multiply by the derivative of the inside. What's the derivative of 2x? It is 2. So this would just be negative 2 sine 2x. Okay, and what was our u prime? 3x squared. So now we are going to say product rule. What does it say? It says if y is equal to uv, then that means dy dx will now be, you bring the second one v, you multiply by the derivative of the first u prime, plus bring the first one u, multiply by the derivative of the second v prime. So this is going to be, if you want, you could have, you can now, let's see, you can now say then that dy dx will be equal to, what is my v? My v is going to be cos 2x. Then I multiply by u prime, which is the derivative of u, which is 3x squared. Plus, you add u, what is my u now? My u is x cubed. Then you multiply by the derivative of v, which is negative 2 sine 2x. And what is this going to give us? 3x squared cos 2x. Then this will become negative x cubed, okay, negative 2x cubed sine 2x. This is what we end up having. This is my dy dx. But now we have a maximum point. So what do we know? We know that at maximum, what happens at maximum now? We have found our derivative, and we know that at maximum, dy dx is equal to 0. Okay? And they also said x will be equal to p. Okay? They said you should make x be p at this point. So what are you going to now have? You now say, what is your dy dx? You'd say 3x squared cos 2x minus 2x cubed sine 2x. This is equal to 0. Okay? Right. And then now we are going to say let x equal to p. Right? So here, first we let dy dx equal to 0. Right? Then we now let x equal to p. So it's going to be 3p squared cos 2p minus 2p cubed sine 2p is equal to 0. Now let's just make what? We have to create a tan. Can you see that we have the tan inverse? So we need to create a tan. We know that tan is sine over cos. So I'm going to take these things with sine to the other side first. So I'll now have 3p squared cos 2p is equal to 2p cubed sine 2p. Then I'm going to do what? I'm going to take this 2p cubed to the other side and this cos 2p to the other side. So what I'll end up having is, let me narrow these things down so that it fits. Okay? Remember, you always write on one side so that if you need space, you can put it. So I'm going to move things like this. Let's see if I can move it. All right. So I actually end up having more space now. So let's utilize that space. What are we going to have? We said now, you're going to say 3p squared over 2p cubed will be equal to sine 2p over cos 2p. That's what makes 10. Okay, we need to make 10. So we'll end up having 3 over, okay, the p squared into p squared 1 into p cubed is a p. So it's 3 over 2p is equal to 10 2p because it's sine 2p over cos 2p. Then we'll take 10 to the other side. We'll end up having, you can now say here that tan inverse of 3 over 2p is equal to 2p. Then you take this 2 to the other side, it will end up being half tan inverse of 3 over 2p. This is equal to p. So we can say p is equal to half tan inverse of 3 over 2p. Is it the same as what they said we should have? Yes, it is. So we have found this and we are done. What was the thing? Find the topic and just do what the topic needs you to do. That's all we did and that's how we got our solution. And we are done. See you in the next video. Goodbye for now.